we're doing a CNC, which is basically stands for Computer Numerical Control, and we're going to do an engraver and then a laser. So in this first part, we're going to need a CNC shield at the bottom left, the red and yellow shield that fits right over an Uno. We're going to need some drivers, which are, we'll see in a bit, and we're going to need these two salvaged DVD or CD devices, or, well, units. And what we're going to do is we're basically going to splice some UTP cable. I used Cat5 that I had lying around, and connect each one of the cable terminals from those salvaged CD units to our drivers on the shield. And lastly, we're going to use a software called GRBL. In this case, 1.1 is the version, which will actually interface with our Arduino IDE. So instead of writing a bunch of Arduino code, we're going to basically send GRBL commands to the Arduino so that it can interpret it and move accordingly. So we're going to use the serial monitor to send commands such as this one, GO X 2.0, Y 2.0, Z 2.0, to interface with our stepper motors using GRBL. Okay, so let's get started with the hardware. This is pretty simple. I used two aluminum angles, equal side angles, one for the horizontal plane and the other one for the vertical plane. We're using two planes because we're going to have two axes controlled by two drivers on the shield, one for the X and one for the Y. And this is what a driver looks like. This is an A4988 stepper driver, and it basically allows for a more precise control of the steppers by regulating the current, but also by letting through a lot more current than what your Arduino Uno can source. So we're going to place these two drivers, two A4988s, on the the two bottom slots of our CNC shield, as you can see here, and they have these adhesive mounted heat sinks that you can connect to them. So what we're going to do is we're going to take connections from each one of our axes to one of these axes drivers. So as you can see, each stepper motor has 4 wires, and we bring in 4 of those wires onto one of these so that it can control the X, and the other one will control the Y. So here you can see a close-up of the actual soldered connections of the UTP cable to each one of the, in this case, 4 wire terminals for the stepper motors of my DVD drives, or CD drives. I don't remember what they were really. So we're also going to need the power adapter. In this case, I'm using it needs to be a 12 volt. I'm using a 12 volt 2 amp capable adapter. We really only need 1 amp, but it does have to be 1 amp because we want that to be the minimum amount of current. Okay, and basically we mount these together, form an L-shaped structure, and mount one of the CD units onto the vertical angle, and the other one we fix it down on the horizontal one. And now we just need to take all those wires over to our CNC shield. Now on top of the bottom one, we're going to mount, in this case I mounted just a foam cutout that I found somewhere, and that's going to allow us to mount something on top of the actual CD head, which is the one that moves around, the one that the stepper actually controls. And I have used an acrylic, basically a square, that I can use to mount my paper on. Okay, so that's going to depend on how big your CD units are. In my case, it wasn't very big, so I believe it's about 10 centimeters by 10 centimeters. And this is what I have. I use double-sided tape so that I can basically tape my paper, which is my drawing surface, onto my acrylic plate. You can also use magnets. Some people use small magnets to hold the paper in place. That's just fine. And here's a even closer look at the connections, soldered connections. I did want to point out that I used hot silicone to actually not only hold those connections in place a little bit, but also to protect them from each other, and we don't want them making sparks or anything like that. Okay, so let's take a look at the software. It does come with a few examples, and this is one of them. It's the circle example. As you can see, the head comes down where the yellow is, and then it goes out to the left, and then it spins around clockwise, I believe, and then it comes back around to the other side. On the square example, it comes down at the top left, and it basically goes right, down, left, up, finishes the square. This is the one that we are going to be using for our simple example. And we do just need to do one more thing before we get started, which is calibrate. We need to find out how many steps of our stepper motors translate into how many centimeters in distance on our plate, because we don't want things to overrun, obviously, and we do want to make a precisely sized drawing. So I have marked out the four corners, what they should be, and I have calculated my distance, and the final result is basically we have the steppers controlling the motor, and that is the motion that is the result of our programming. Okay, so next we're going to move on to a more complicated one, way cooler, an actual laser engraver. So don't forget to like, share, and subscribe, and I'll see you.